On October 20th, 2025, that is precisely what happened. The digital heartbeat of our civilization, a pulse we had come to take for granted as constant as the sunrise, faltered, stuttered, and in many places, simply stopped. It began in the pre-dawn darkness on the east coast of the United States, a time when the global network is never truly asleep, merely shifting its weight. At 3:11 a.m. Eastern Time, the first ripple of dysfunction emerged, a sluggish app, a frozen bank transfer, a social media feed that refused to refresh. This trickle of inconvenience rapidly swelled into a torrent of silence. Snapchat, a platform built on ephemeral moments, found its own existence frozen in time. Fortnite servers, virtual worlds teeming with millions, became ghost towns. Amazon's Alexa, the disembodied voice in millions of homes, fell mute, and Ring doorbells stared out onto streets with unseeing digital eyes. Banking portals displayed spinning wheels where balances should be, and streaming services choked on their own buffers. This was not an isolated technical glitch. It was a systemic seizure, a catastrophic wound inflicted upon the invisible grid we have woven around our planet. A second atmosphere of data and connection that had, in a terrifying moment, begun to suffocate. The source of this digital hemorrhage was quickly triangulated. Amazon Web Services US East 1, a colossal cloud computing region nestled in Northern Virginia, one of the oldest and most critical nerve centers of the entire internet. When this region hiccups, the world feels a shudder. When it collapses, the world holds its breath. And as millions stared at loading screens that would never load, as engineers scrambled in data centers whose very monitoring systems were failing, another disappearance was underway, one not of our own making, but one whose timing would echo with an unnerving resonance. Almost exactly 24 hours later, on October 21st, from our perspective on Earth, the interstellar visitor known as 3I Atlas, only the third confirmed object from another star system to ever enter our solar system, slipped silently behind the sun, entering a period astronomers call solar conjunction. It vanished from our view, entering a cosmic blind spot. Two disappearances, one digital, one celestial, separated by a mere day. A coincidence, surely. The universe is vast, and our pattern-seeking brains are notorious for drawing lines between unrelated points. But what if, for a moment, we dare to ask, what if the lines are real? Before we descend further into this labyrinth of timing and implication, I want to pause and acknowledge you, joining me in this investigation. The very fact that you are here, questioning, probing, signifies a refusal to accept the surface-level narrative. Where are you watching from right now? What time is it there? Is it the middle of the night, with the darkness outside your window mirroring the digital darkness we're discussing? Or is it the middle of the day, the bright sun a stark contrast to the shadowy events we are unraveling? Wherever you are, your perspective is part of this story. If you want to stand with us on the front lines of these investigations, to be there as each new piece of this puzzle is revealed in real time, I urge you to subscribe to this channel. You are the reason we chase the stories that lurk in the blind spots, the narratives that others are too hesitant to follow. By subscribing, you ensure you don't miss a single development as this unprecedented situation continues to unfold. Now let us begin our descent into the anatomy of this dual mystery, starting with the moment our world, digitally, went silent. The official explanation from Amazon Web Services was a masterclass in technical jargon, a litany of failures that, to the uninitiated, sounded like a foreign language. Increased error rates and latencies in the US East 1 region, issues with DNS resolution, failures in the internal monitoring subsystem, and problems with DynamoDB endpoints. Let us translate this from engineer speak into the language of catastrophe. DNS resolution is the internet's phone book. When it fails, computers can no longer find each other in the vast digital metropolis. The internal monitoring subsystem is the nervous system of the data center. When it goes dark, the engineers who are the doctors for this digital body are left blindfolded, unable to diagnose the patient's ailment. DynamoDB endpoints are the foundational databases that countless applications rely on to store and retrieve information. When they become unreachable, it is as if the very memory of the system has been wiped clean. This was not a single point of failure. It was a perfect storm of interconnected collapses, each one amplifying the others in a devastating cascade. The true fragility of our modern internet architecture was exposed in its terrifying dependency. Your banking app does not simply talk to your bank's servers. It authenticates your identity through third-party services. It routes traffic through content delivery networks. It makes API calls to dozens of different systems, many of which, by design or by chance, were funneled through the very heart of AWS US East 1. When that heart stopped beating, the shock waves did not merely radiate outward. They ricocheted through a hall of mirrors, each reflection a new service, a new company, a new life disrupted. Think of it not as a single tree falling, but as the keystone in a vast global arch crumbling. The entire structure, which we believe to be redundant and resilient, wobbled and threatened to collapse. The Guardian described this outage as revealing how internet users are at the mercy of too few providers. And that is not hyperbole. It is a cold, hard fact. 3 companies, Amazon, Microsoft, and Google, control the majority of the cloud computing infrastructure upon which the modern world is built. We have built a global network where too many roads lead through a single fragile tunnel. And on October 20th, 2025, that tunnel caved in. What we do not yet know is perhaps more terrifying than what we do. Amazon has not released a detailed forensic timeline. There has been no public indication of a malicious attack, no evidence that a bad actor deliberately pulled this trigger. But absence of evidence is not evidence of absence, especially when the full investigation is still shrouded in corporate secrecy. We do not know precisely which system failed first, which failures were symptoms and which were causes, or whether there were any unusual patterns in the error logs that might whisper of something beyond a routine technical malfunction. Third-party monitoring services like Thousand Eyes confirmed the massive scope from outside Amazon's network. Watching the digital packets drop and connections time out like a doctor observing a patient's vital signs crash. But they could not see inside the patient's body. They could not perform the autopsy to understand the root mechanism of death. That examination is happening behind closed doors, in conference rooms at Amazon, and in the offices of regulators, who are only now beginning to ask the uncomfortable questions about this dangerous concentration of power. So, here is what we can say with confidence. On October 20th, 2025, one of the most critical pieces of internet infrastructure on the planet experienced a cascading failure that disrupted the global flow of information for hours. The technical cause involved multiple interconnected system failures in a single geographic region. The impact was instantaneous and universal, touching everything from social media to financial services to the very doorbells on our homes. The recovery was a slow, painful slog, even with thousands of the world's most brilliant engineers working around the clock. And the vulnerability, the profound fragility of our centralized digital architecture remains, for the most part, unaddressed. We have documented the symptoms. We have identified the patient, but we are still a long way from understanding or curing the underlying disease. Now, let us flip the coin from the digital to the cosmic and meet the other player in this story of simultaneous disappearance. On July 1st, 2025, astronomers at the Asteroid Terrestrial Impact Last Alert System, or ATLAS, detected something extraordinary. A new object was moving through our solar system, but not like the comets and asteroids we are used to seeing, those born from the primordial cloud that formed our own sun. This object had a trajectory that was hyperbolic, a path that pointed backward, away from the sun's gravitational well, suggesting it was a tourist merely passing through, a visitor from the vast dark sea between the stars. Further observations confirmed this breathtaking hypothesis. This was an interstellar object, only the third such object ever definitively confirmed in human history. They named it 3I Atlas, the 3I denoting the third interstellar object, a name that carries the weight of its rarity. Its predecessors were the bizarre, elongated 1I Oumuamua that passed through in 2017 and confused everyone with its strange acceleration, and the more conventional-looking comet 2I Borisov discovered in 2019. Now, we had a third messenger from a distant, unknown star system, arriving unannounced and moving at speeds that would liquefy any spacecraft humanity has ever built. These interstellar objects are cosmic wanderers, chunks of rock and ice ejected from the gravitational turmoil of other solar systems, destined to drift through the galactic void for millions or billions of years until they happen to pass close enough to our sun for us to notice their fleeting presence. They are scientifically precious, each one a sealed capsule carrying the chemical and physical history of its home star. The orbital trajectory of 3I Atlas showed it was approaching the sun, with its perihelion, its point of closest approach, calculated to occur around October 29th, 2025, at a distance of about 136 astronomical units, or roughly 210 million kilometers from the sun. But here is where our story of observability and its loss becomes critical. As any object approaches the sun from Earth's perspective, there comes a point where the angle between the object, the Earth, and the sun becomes too small. This is the moment of solar conjunction. When this solar elongation drops below about 30 degrees, ground-based telescopes struggle mightily and then fail completely to observe the object. It is swallowed by the overwhelming, blinding glare of our star. It is like trying to spot a single lit match held up next to a massive searchlight. For 3i Atlas, this observational blackout period began around October 21st, 2025. From our viewpoint on Earth, the comet moved behind the sun. Our most powerful eyes on the sky went effectively blind to its position, its behavior, its very existence. This blackout would last for days, or potentially weeks, depending on its speed and trajectory. And just as it was getting scientifically interesting, just as the sun's heat was ramping up and beginning to sublimate its ices, releasing dust and gas to form a glowing coma and tail, just as we might have witnessed it fragment or behave in unexpected ways, it vanished behind a curtain of pure light. We lost our ability to watch at the most dynamic phase of its entire journey through our neighborhood. Let me now draw for you a precise picture in time, a chronology that forms the unsettling core of this investigation. On October 20th, 2025, at approximately 3:11 a.m. Eastern Time, Amazon Web Services US East 1 begins experiencing critical cascading failures. This is a documented, time-stamped, and verified event, witnessed by millions of users and multiple independent monitoring services. The digital heartbeat of civilization stutters and falters. Then, just 24 hours later, on October 21st, 2025, 3i Atlas reaches its solar conjunction window. The geometric angle drops below the threshold for reliable observation. Ground-based telescopes lose their lock. The interstellar visitor, this rare messenger from the cosmos, effectively vanishes from our monitoring capability. This timing is also documented and calculable, a certainty derived from the immutable laws of orbital mechanics. Both events are real, both are verified, and they occur within a breathtakingly narrow 48-hour window of each other. To add another layer of context to this compressed time frame, late October 2025 also saw a noted increase in solar activity. Active sunspot regions were growing on the sun's surface, and space weather forecasters were monitoring the potential for solar flares and coronal mass ejections. We are, after all, approaching the peak of the sun's 11-year activity cycle, a period known as solar maximum. So, we have three significant phenomena converging: a major, centralized cloud infrastructure failure, an interstellar object entering an observational blackout, and heightened solar activity. Any one of these alone would be noteworthy. All three together in such a tight sequence creates a confluence that starts to look less like random chance and more like a carefully, almost artistically, arranged coincidence. The concept of blind spots is the crucial thread that binds these events together. In the digital realm, when AWS US East 1 failed, we did not merely lose services, we lost our visibility into what was happening. The monitoring tools themselves failed. The diagnostic data became unreliable. The very systems we used to understand the system were compromised. Engineers were flying blind, troubleshooting a cascading catastrophe with incomplete, often contradictory information. In the astronomical realm, when 3i Atlas entered solar conjunction, we lost our direct observational capability. We were forced into a position of waiting, of ignorance, unable to see what this scientifically unique object was doing during the most intense part of its solar encounter. Two different types of blindness in two completely separate domains of human endeavor, occurring in near-perfect synchrony. The metaphor is irresistible. It is as if the power grid fails, plunging your city into artificial darkness. At the exact same moment, a cloud bank obscures the moon and the stars. You are left in a dual darkness, a void of both human-made and natural light. During that window of dual blindness, maybe nothing of consequence happens. Maybe you simply wait for the lights to come back on and continue with your life. But during the blackout itself, you have no way of knowing what you might be missing. You have no way of confirming that everything is proceeding normally, because you cannot see anything proceeding at all. That is the precise, unnerving situation we are examining here. A window where both our technological monitoring and our cosmic observation went dark together. Before we venture any further down the rabbit hole of implication and speculation, it is absolutely essential that we establish a firm foundation of rational skepticism and address the strongest counterarguments to any hypothesis that these events are meaningfully linked. The burden of proof for claiming a connection is, and should be, exceptionally high. So let us lay out the undeniable, evidence-based counterpoints. First, cloud outages, even major ones, are not rare. Amazon Web Services has experienced multiple significant incidents in US East 1 over the years. There was a major outage in December 2021 that took down huge swaths of the internet for hours. There have been smaller incidents consistently throughout 2023 and 2024. These are unfathomably complex systems operating at a scale that defies human comprehension, handling traffic loads that are almost imaginary in their magnitude. Sometimes they fail. Sometimes the very monitoring and automated recovery systems designed to prevent failure are the ones that fail. Treating this specific outage as uniquely suspicious requires evidence that goes far beyond a simple timing coincidence. Second, 3i Atlas is not close to Earth and poses no physical threat. Its perihelion keeps it well over 200 million kilometers from the Sun and even farther from Earth. The object is small, probably only a few kilometers across, a cold chunk of ice, rock, and organic compounds. The idea that this comet could somehow affect Earth's technology from that immense distance defies the fundamental laws of physics as we understand them. The electromagnetic radiation it reflects is negligible, its gravitational influence is non-existent, and any particles it releases are dissipated into the void of space long before they could ever reach us. There is simply no known mechanism for a causal link. Third, and perhaps most definitively, there is no evidence of unusual solar or geomagnetic activity during the outage window. Our space weather monitoring network is extensive and continuous, comprising multiple satellites, ground-based magnetometers, and forecasting centers that watch the sun with unblinking vigilance. During the period of the AWS outage, there were no major Earth-directed solar events recorded, no X-class flares aimed at our planet, no significant coronal mass ejections, no geomagnetic storms of a magnitude that could disrupt satellite operations or power grids. The solar activity that did occur was within the normal elevated parameters expected during solar maximum. If the outage had been caused by space weather, we would have clear, unambiguous evidence. Satellite operators would have reported issues. Power grids in vulnerable regions would have seen fluctuations. Other internet services and providers that did not rely on AWS would have experienced parallel problems. None of that happened. The disruption was isolated, almost surgically, to AWS infrastructure and the services dependent upon it, which strongly, overwhelmingly, suggests an internal technical cause rather than an external cosmic one. These counterpoints represent the mainstream scientific and engineering consensus, a consensus built on decades of empirical observation, rigorous physics, and statistical analysis. It is the baseline, the null hypothesis, and it is almost certainly correct. Any alternative explanation must overcome these formidable objections with compelling, reproducible evidence. And as of now, that evidence simply does not exist. To truly comprehend the devastating impact of the October 20th outage, one must move beyond the surface-level explanation and understand the profound architectural fragility it revealed. Amazon Web Services US East 1 is not merely a data center. It is an intricate, layered ecosystem of availability zones, separate facilities with independent power, cooling, and networking, all clustered in Northern Virginia. The design philosophy is one of redundancy. If one zone fails, traffic should automatically and seamlessly redirect to others. That is the elegant theory. The practice, as witnessed on that day, was a horrifyingly complex tragedy. The infrastructure of a modern cloud region is a tower of abstractions. At its base is the physical hardware: servers, storage devices, network switches, and routers. Upon this rests a virtualization layer, allowing multiple virtual machines to run on single physical hosts. Above that, container orchestration systems manage thousands of application instances. Higher still are load balancers, identity and authentication systems, DNS resolution services, monitoring and alerting systems, and the foundational databases that track configuration and state. Each layer is utterly dependent on the layers below it, and countless services depend on shared infrastructure components that cut across all layers, creating a web of interdependency so dense that a single pulled thread can unravel the entire tapestry. When AWS cited problems with network connectivity, identity services, DNS resolution, and DynamoDB endpoints, they were describing the failure of this tower at multiple critical levels simultaneously. It was a catastrophic cascade. where each failure amplified the next. Applications that needed to authenticate users found the identity services unresponsive. Applications that needed to locate resources found the DNS system inscrutable. Applications that needed to read or write data found the databases unreachable. And because modern applications are mosaics of microservices, often depending on all three of these systems to complete a single user request, the combined failure meant total systemic collapse. The cruelest irony was that the monitoring systems designed to detect and report these very problems were themselves victims, dependent on the same crumbling infrastructure. Engineers were not just fixing a broken system, they were diagnosing a patient in a coma without a heart monitor or an EEG, forced to rely on instinct and fragmented information. Historical context makes this event even more significant. Each major outage, like the one in December 2021, teaches a new, harsh lesson about system fragility. The pattern is clear. Redundancy and fault tolerance, while powerful, are not absolute guarantees. They work until they don't, until a specific, often unpredictable, combination of failures overwhelms the defensive mechanisms, and the cascading effects spread faster than any automated system or human team can respond. The internet is not as distributed as we comfort ourselves into believing. Critical authentication systems, payment processing gateways, API control planes, these are often centralized for consistency and efficiency, creating invisible choke points. When that central point goes down, services hosted elsewhere can still be crippled because they cannot complete the critical operations that require calling home to the failed region. We have built a digital world with the efficiency of a star system, but the vulnerability of a house of cards. Let us now turn our gaze upward to the space environment surrounding our planet during this period and ask the provocative question, even if 3i Atlas itself was not a direct cause, could the broader solar context have contributed in some way? The sun is not a placid, constant ball of light. It is a roiling, chaotic sphere of plasma, its magnetic field constantly twisting and snapping, releasing immense amounts of energy in the form of solar flares and coronal mass ejections, CMEs. We are currently in or near the solar maximum of cycle 25, a period of heightened activity, and mid-October 2025 did indeed see active sunspot regions growing on the solar disk. The space weather environment was, in a word, elevated. When we discuss space weather affecting Earth, we are typically talking about a few specific mechanisms. Solar flares, which bathe Earth in X-rays and extreme ultraviolet light within minutes, potentially disrupting the ionosphere and radio communications, and CMEs, billion-ton clouds of magnetized plasma that take 1 to 3 days to arrive, which can trigger intense geomagnetic storms, damaging satellites, disrupting power grids, and interfering with navigation systems. So, could any of this have been the hidden hand behind the cloud infrastructure failure? The direct answer, based on all available data, is almost certainly no. The servers in AWS data centers are ground-based, shielded by Earth's thick atmosphere and its protective magnetic field. However, there are indirect pathways to consider. Some data centers use satellite communications for backup connectivity or long-haul routing. Many network systems rely on GPS satellites for exquisitely precise time synchronization, a critical but often overlooked function. If space weather were severe enough to disrupt satellites, it could theoretically create ripple effects down on the ground. But here is the definitive point. There is no record of significant satellite disruptions during the October 20th outage window. Communication satellites functioned normally. GPS accuracy was maintained. The indices used to measure geomagnetic storm intensity showed no major events affecting Earth. Now, let us briefly address the most fringe speculation surrounding 3i Atlas itself. The idea that it, as an interstellar object with an unusual composition, could possess some unknown property or emit some form of energy that interfered with our technology. This idea, while a staple of science fiction, has zero evidentiary support in science fact. The physics does not work. The energies are off by orders of magnitude, and the observations of the comet before conjunction showed it behaving like a comet, albeit a chemically interesting one. The scientific verdict is clear and unanimous. No credible mechanism exists by which 3i Atlas could have directly caused the AWS outage. The space environment was active, but not anomalously so. The cosmic visitor was distant and inert from a technological perspective. The timing coincidence, therefore, remains just that, a coincidence. albeit a stunning one that challenges our narrative sensibilities. We now cross a clear line from established fact into explicitly speculative territory. What follows are not accusations or claims, but rather structured thought experiments. Scenarios that explore how one might interpret this coincidental timing if they were looking for patterns, or indeed if they were an actor planning an operation. We will examine 3 high-level scenarios, weighing what each would require and what evidence, if any, we might expect to find. Scenario A: a cyber attack timed with the cosmic window. Imagine a sophisticated state-sponsored cyber actor with the capability to disrupt cloud infrastructure. They learn of the impending solar conjunction of 3I Atlas, a rare astronomical event that will create a natural blind spot and a compelling, distracting narrative. They time their attack for this window. The motive? To create maximum confusion, to obscure forensic analysis within the noise of a cosmic coincidence, to perhaps even test responses during a moment of dual vulnerability. This scenario requires advanced knowledge of the conjunction, which is public, the capability to trigger a cascading cloud failure, non-trivial but plausible, and a motive that values symbolic timing over pure stealth. What would we expect to see? Evidence of unauthorized access in network logs, indicators of compromise, forensic signatures of coordinated malicious activity. What do we actually see? Amazon has stated there is no evidence of a malicious attack. No cybersecurity agency has issued related alerts. The failure patterns appear consistent with internal technical cascades. This doesn't rule out a perfectly mimicked attack, but it adds a layer of unproven complexity. Scenario B: a cosmic incident triggering a chain reaction. This is the most physics-defying scenario, and we must be blunt about its implausibility. The speculation would posit that 3I Atlas, through some unknown property or interaction with the solar wind, emitted a burst of energy or triggered a space weather effect that propagated to Earth, disrupting satellites, which in turn cascaded to ground infrastructure. This would require a completely novel physical mechanism, one we have never observed. We would expect to see widespread satellite malfunctions across multiple operators and constellations, clear space weather anomalies, and effects not isolated to a single cloud provider. What do we actually see? None of that. Satellite operations were normal. Space weather was elevated but not extreme, and the outage was confined to AWS dependencies. This scenario fails on virtually every evidential requirement. Scenario C: the outage as opportunistic cover. Here, the outage is accepted as a genuine technical failure. However, another actor, perhaps with insider knowledge of the impending instability or simply monitoring for chaos, uses the window of distraction to conduct other activities. Data exfiltration, network repositioning, or testing systems while defenders are focused on restoration. The cosmic timing is coincidental, but the infrastructure failure creates a real operational opportunity. This requires either foresight or rapid response capability. We would expect to see subtle secondary anomalies in forensic logs that are unrelated to the root cause. This scenario is the most difficult to disprove, as its signatures would be deliberately hidden within the legitimate chaos of the outage response. There is no public evidence of this, but its clandestine nature means absence of evidence is not definitive. These scenarios map the landscape of possibility, from the mundane to the extraordinary. The key takeaway is that while the rational baseline of coincidence remains strongest, the very act of exploring these possibilities forces us to confront the vulnerabilities they would exploit. Vulnerabilities that are very, very real. When 3I Atlas moved behind the sun, it entered an observational blackout that is a fundamental, unyielding limitation of our position in space. This is not a failure of technology that better engineering can solve. It is a problem of pure geometry. The sun is so overwhelmingly bright that anything within about 30 degrees of it becomes invisible to ground-based optical telescopes. Specialized instruments like coronagraphs can observe closer, but they are not designed for tracking small, fast-moving comets. For 3I Atlas, this meant a blackout lasting weeks, a period that crucially included its perihelion, its closest approach to the sun, on or around October 29th. This is the moment of maximum solar heating, the point where the comet would be most dynamic, most active, most likely to fragment or exhibit spectacular outbursts, and we missed it all. Astronomers had been gathering precious data since its discovery in July, piecing together the story of this visitor from another star. Then, just as the plot was reaching its climax, the curtain fell. The data stream ended. Telescope time was allocated to other targets. The universe does not pause for our observational limitations. Who watches when an object goes behind the sun? Ground telescopes cannot. Space-based telescopes like Hubble or the James Webb Space Telescope have strict pointing constraints to avoid damaging their sensitive instruments by accidentally looking at the sun. They cannot track objects through conjunction. Specialized solar observatories might catch a glimpse of a brilliantly bright comet, but 3i Atlas was not nearly bright enough. The only potential for observation would have been from a different vantage point in the solar system, such as an orbiter around Mars. But Mars-based assets are few, their time is precious, and coordinating such observations requires planning that likely did not occur for this object. The result is a definitive surveillance gap, a hole in our data that can never be filled. We will never know with certainty what 3i Atlas did during those weeks. Did it fragment quietly? Did it have a massive outburst? Did its rotation change due to asymmetric jetting? This is a genuine loss for science, a permanent gap in our understanding of interstellar objects. Connecting this back to our larger narrative, the parallel is stark. At almost the same time, our digital infrastructure experienced a failure that blinded our technological senses. Our astronomical systems experienced a geometric failure that blinded our cosmic senses. Both our created and our natural monitoring capabilities were simultaneously impaired. It is a poetic and unsettling symmetry, a moment when humanity's awareness of both its own networks and its cosmic neighborhood was temporarily and coincidentally dimmed. We have now assembled all the core components of this mystery: the detailed technical failure of the cloud, the precise astronomical mechanics of the conjunction, the compelling timing overlap, and a spectrum of speculative scenarios. It is time to organize this information into a coherent framework, a narrative matrix to evaluate which explanations hold weight and which collapse under scrutiny. We can judge each scenario against three key criteria: timing, how well it explains the coincidence; means, the plausible mechanism required; and motive, the strategic benefit. Let's apply this filter. Scenario 1, pure coincidence. Timing. The overlap of two rare events is statistically unlikely, but not impossible in a complex world. Means, no mechanism required. Both events have independent, well-understood causes. Motive, not applicable. This is the most parsimonious explanation, adhering to Occam's razor. It matches all available evidence but can feel emotionally unsatisfying. Scenario 2, coincidence worth documenting. This is essentially scenario 1, but with the intellectual honesty to state that rare coincidences, even if meaningless, are worthy of investigation because they highlight independent vulnerabilities. Its strengths are its adherence to fact and its constructive focus on systemic fragility. Scenario 3, deliberate cyber attack. Timing, perfectly explained by planning. Means, requires sophisticated cyber capability and cross-domain awareness, both plausible. Motive, distraction, symbolic messaging, operational security, possible but not overwhelmingly compelling. Its weakness is the total lack of evidence, making it an unsupported complication. Scenario 4, cosmic interference. Timing, perfectly explained. Means, requires unknown physics, completely implausible and contradicted by all data. Motive, not applicable if natural. This scenario fails utterly on the means criterion and must be rejected. Scenario 5, opportunistic exploitation. Timing, accepts the coincidence but exploits the resulting chaos. Means, requires ability to act during outages, which many actors possess. Motive, data theft, network access, highly plausible. Its weakness is the difficulty of finding evidence, but it remains a credible, if unproven, threat model. Walking through this matrix, the conclusion is inescapable. The simplest explanation that fits all the verified facts is pure coincidence. The AWS outage was a catastrophic but internally generated technical failure. The disappearance of 3i Atlas was an inevitable astronomical event. Their temporal proximity is a narrative hook crafted by chance, one that our pattern-seeking brains find irresistible. Yet this investigation is far from a waste of time. By following these threads, we have been forced to confront profound truths about the fragility of our digital infrastructure and the limitations of our cosmic awareness. The value is not in proving a conspiracy, but in illuminating the very real vulnerabilities that a conspiracy would exploit. To fully appreciate the nature of cosmic blind spots, we We must journey from the inner solar system to the deep ice of Antarctica, and a discovery that underscores how much of the universe's drama we miss. On September 19th, 2025, the IceCube Neutrino Observatory, a cubic kilometre of ice instrumented with thousands of sensors, detected something extraordinary, a neutrino event designated IceCube 250919A. This was not just any particle. Neutrinos are ghostly subatomic entities that interact with matter so rarely that trillions pass through your body every second without a single collision. This particular neutrino, however, was caught, and its energy was staggering, approximately 290 tera-electron volts, tens of thousands of times more energetic than anything produced in the Large Hadron Collider. It was a cosmic messenger from an event of unimaginable violence, likely born in the heart of a supermassive black hole tearing apart a star, or a jet of plasma moving at near-light speed. It had travelled across intergalactic space, passed through the entire Earth as if it were empty space, and deposited a tiny fraction of its immense energy in the Antarctic ice. The detection came 12 hours after the event itself. That is the nature of neutrino astronomy. We are always late to the party. Automated alert systems immediately notified optical telescopes, radio arrays, and gamma-ray observatories around the world. They scrambled to scan the patch of sky in the constellation Ursa Major from which the neutrino had come, but they found nothing. No supernova, no gamma-ray burst, no flaring blazer, just the neutrino, a solitary, screaming messenger from a cataclysm we could not see. Think about the profound implication of this. An event of colossal power, capable of accelerating a single particle to energies we can barely comprehend, occurred in the depths of space, and we would have known absolutely nothing about it if not for a billion-dollar detector buried under a mile of ice. The universe is constantly performing its violent acts, and we are largely oblivious. This is the ultimate blind spot. Our eyes on the sky, our optical and radio telescopes, see only a sliver of the electromagnetic spectrum. Neutrinos, gravitational waves, ultra-high energy cosmic rays. These are other, more elusive channels of information. For everyone we catch, thousands, millions, perhaps billions more pass by unnoticed. The IceCube detection is a perfect analogy for the infrastructure outage. One moment, everything is normal. The next, you realize something massive and consequential has happened, and you were almost completely blind to it. The difference is one of scale. When the internet goes down, the effect is immediate and personal. When a neutrino from a distant catastrophe passes through you, you feel nothing. But both events reveal the same truth. Our awareness is partially a constructed illusion built on the limited senses we have chosen or been able to build. The cloud outage was a failure of logic and software, but our digital world rests on a physical foundation that is equally, if not more, fragile. To understand this, we must rewind to March 7th, 2025, an event that serves as a stark prelude to the October crisis. At approximately 4:30 a.m. Central European Time, the southern telecommunications backbone running through the Mediterranean Sea suffered a catastrophic failure event. 3 major submarine fibre optic cables, the AAE-1, the CME-W5, and the Italy-Greece 1 corridor, went dark simultaneously. These are not mere wires. They are the transoceanic arteries of the internet, thick bundles of hair-thin glass fibres carrying pulses of light that constitute 40% of the data flowing between Europe and Asia. In an instant, they stopped. The impact was immediate. Internet service providers across southern Europe saw their capacity plummet by 60–70%. Cloud services hosted in regional data centers became unreachable. Video calls froze. Financial transactions timed out. Streaming died. This was a hard stop, a digital amputation. Redundancy, the mantra of the internet, failed spectacularly. When you lose 3 major cables at once, the remaining paths are instantly overwhelmed, like trying to funnel the traffic of a 10-lane highway down a single country road. The official explanation, delivered hours later, was a chillingly improbable coincidence. A combination of seismic activity near Crete and possible anchor dragging from commercial shipping in international waters. 2 separate, unconnected incidents, happening almost simultaneously, affecting 3 separate cable systems. The probability is astronomically low but not impossible. Repairs would take weeks, requiring specialized cable-laying ships and remotely operated vehicles to grapple with cables on the seafloor thousands of meters down. This event exposes the fundamental lie of the cloud. It is not an ethereal distributed entity. It is a physical network of copper, glass, and steel, laid across the ocean floor and vulnerable to earthquakes, ship anchors, and even the occasional curious shark. Experts have warned for years that the internet has the same vulnerability profile as the telegraph networks of the 1800s. Concentrated landing points and shared routes through geographic choke points. The Mediterranean is one such choke point. The Suez Corridor is another. The English Channel another. To cripple global internet traffic, you would not need to cut thousands of cables. A dozen strategic cuts in these locations would unleash global chaos. The March 7th cable cuts were a dramatic demonstration of physical vulnerability, just as the AWS outage was a demonstration of logical vulnerability. Together, they paint a picture of a system that is robust against single points of failure, but terrifyingly fragile when multiple correlated failures occur. Our vulnerability extends beyond the ground and the oceans, into the very space around our planet. On May 10, 2025, the Sun provided a stark reminder of its power. A massive coronal mass ejection, CME, erupted from active sunspot region 3691, a cluster twice the diameter of Earth. This was not mere solar wind. It was a coherent billion-ton bubble of magnetized plasma hurled into space at over 2 million kilometers per hour. The initial analysis from NOAA's Space Weather Prediction Center was alarming. The CME's trajectory appeared to be Earth-directed. If it hit, it would trigger a severe G4 to extreme G5 geomagnetic storm, the kind last seen in the Carrington event of 1859. The potential consequences were sobering. Widespread voltage control problems in power grids, possible transformer damage, induced currents in pipelines, satellite navigation degraded for days, high-frequency radio blackouts, and auroras visible as far south as the equator. The world held its breath. Power grid operators went on high alert. Satellite operators prepared for increased drag and potential electronic upsets. The clock was ticking. The CME would take approximately 48 hours to arrive. Then the models were updated. New data from the Solar and Heliospheric Observatory, SOHO, and the Deep Space Climate Observatory, DSCOVA, showed a critical shift. The bulk of the CME's core would pass just ahead of Earth's orbital path. We would receive a glancing blow, not a direct hit. The forecast was downgraded to a moderate G2 storm. The collective sigh of relief from the global infrastructure community was almost audible. When the storm arrived on May 12th, the effects were noticeable but manageable. Enhanced auroras, minor power grid fluctuations, and some brief satellite communication issues. It was a near miss, a cosmic warning shot across our bow. The May 10th event demonstrates two things with absolute clarity. First, our space weather monitoring and prediction capabilities have advanced tremendously. We saw the threat coming days in advance, allowing for preparations that would have been impossible a generation ago. Second, despite this, our infrastructure remains profoundly vulnerable to a direct hit. A G5-level storm striking Earth would not be a temporary inconvenience. It would be a global catastrophe, causing long-term, widespread power outages and crippling satellite services for months or even years. This near-miss event is a crucial data point in our timeline. It proves that the space environment can and does produce threats capable of disrupting our technological civilization. It establishes that the Sun was active and capable of producing Earth-directed events in 2025. And it highlights the critical difference between a near-miss and a direct hit. A difference that, in October, we must remember, did not occur. The solar environment during the AWS outage was not the culprit, but the May event stands as a permanent reminder that the threat is real, and our luck will not hold forever. Let us now step back and view the year 2025 not as a series of isolated incidents, but as a cascading timeline of systemic stress, a pattern that reveals the underlying fragility of our hyperconnected world. We begin on March 7th with the catastrophic failure of 3 major submarine internet cables in the Mediterranean, a physical blow to the internet's backbone that crippled connectivity between continents for weeks. This was a failure of redundancy and a demonstration of geographic choke points. Then, on May 10th, we have the solar near-miss, a coronal mass ejection that could have triggered a global technological crisis had its trajectory been a fraction of a degree different. This was a reminder of our vulnerability to external cosmic forces. On July 1st, the discovery of 3I Atlas adds a new, enigmatic element to the cosmic stage, a rare interstellar visitor on a trajectory that will take it behind the Sun. The plot thickens. On September 19th, the IceCube neutrino detection reveals a hidden, violent universe operating in channels we are only beginning to monitor, a stark lesson in our observational blind spots. And then, the crescendo, October 20th, the AWS US East 1 outage, a logical and architectural failure in one of the most critical nodes of our digital cloud. This is followed within 24 hours by the solar conjunction of 3I Atlas, plunging the interstellar object into an observational blackout. This timeline is not evidence of a conspiracy. It is evidence of complexity. We have built a civilization of immense technological sophistication, but that sophistication has created new, emergent forms of risk. The physical risk of undersea cables, the cosmic risk of space weather, the logical risk of centralized cloud architecture, the scientific risk of observational gaps. These risks are not connected by a hidden hand. They are connected by the simple fact that they all exist simultaneously within the complex system that is modern human civilization. When you have many independent systems operating at the edge of their capacity, the probability of multiple, seemingly related failures occurring in a short time frame increases. It is the mathematical law of large numbers applied to global risk. The pattern is not one of deliberate orchestration, but of systemic stress. Each event is a tremor along a different fault line in our technological world. The Mediterranean cable cuts were a tremor along the physical fault line. The solar CME was a tremor along the space weather fault line. The AWS outage was a tremor along the cloud architecture fault line. The fact that we felt tremors along multiple fault lines in a single year is not proof they are connected by a single underlying cause, but it is a powerful warning that our entire system is under stress. We are living in a house built on multiple, independent geological faults. We have been lucky that they haven't all slipped at once. The events of 2025 are the creaks and groans from the foundation, telling us that our luck may be running out. Why does the coincidence of the AWS outage and the 3I Atlas conjunction feel so significant, even when the rational part of our brain acknowledges the overwhelming likelihood of independent causes? The answer lies deep within the architecture of the human mind. We are, by evolutionary design, pattern recognition machines. For our ancestors on the savannah, seeing a pattern in the rustling grass, a pattern that might indicate a predator, was a matter of life and death. It was far safer to assume a pattern was real and be wrong than to assume it was random and be eaten. This cognitive bias, known as apophenia, the tendency to perceive connections and meaning between unrelated things, is a fundamental feature of our psychology, not a bug. In the modern world, flooded with information and abstract threats, this ancient wiring can misfire. We see faces in clouds. We hear hidden messages in recorded music played backward. And we connect a cloud computing failure with a comet disappearing behind the sun. Our brains are desperate to weave the disparate threads of our experience into a coherent narrative, a story with a cause and an effect. A random, meaningless coincidence is cognitively unsatisfying. It feels like an unfinished sentence. A story of hidden connections, even if speculative, feels more complete, more true to our narrative-hungry minds. This psychological drive is amplified by the very nature of the digital age. We are constantly bombarded with information, a fire hose of data points from around the globe. In such an environment, the sheer number of potential connections increases exponentially. Given enough data points, stunning coincidences are not just possible. They are inevitable. It is a mathematical certainty. If you track enough rare events, major internet outages, significant astronomical events, political upheavals, financial crashes, sooner or later, some of them will align in time in a way that seems impossibly meaningful. This is the essence of the clustering illusion, where we perceive clusters in random data. The human factor is the final, and perhaps most important, piece of this puzzle. We are not dispassionate logic engines. We are storytellers. The narrative of a cosmic event affecting our technology is a powerful story, one that taps into ancient myths and modern science fiction. It is far more compelling than the dry, complex, and ultimately mundane story of a software bug triggering a cascading failure in a data center. To truly understand the events of October 2025, we must understand not only the physics of the comet and the engineering of the cloud, but also the psychology of the observers. We are part of the story. Our desire for meaning is a variable in the equation. Recognizing this bias is the first step toward a clearer, more rational view of the world. It allows us to acknowledge the eerie coincidence for what it is, a compelling narrative hook, while still accepting the overwhelming evidence for a mundane, a frightening reality. In the immediate aftermath of the AWS outage, as millions of people found their digital lives frozen, a parallel event unfolded in the spaces that remained online. The battle for the narrative. On platforms like X, formerly Twitter, Reddit, and Telegram, explanations for the event proliferated at the speed of light, unfettered by evidence or fact-checking. The official silence from Amazon in the first critical hours created a vacuum, and nature, as it is said, abhors a vacuum. Into this void rushed a torrent of speculation, misinformation, and deliberate disinformation. The mainstream narrative, championed by tech journalists and industry analysts, coalesced around the cascading failure theory. This was the safe, technically grounded explanation, based on historical precedent and the known complexities of cloud architecture. It was the story told by Wired, The Verge, and CNBC, but competing narratives flourished in the digital underground. For some, it was a cyber attack, a Russian test of critical infrastructure, a Chinese prelude to something larger, or an Iranian show of force. For others, it was a government drill, a planned outage to test public response or to conduct hidden operations under the cover of chaos. And for a significant subset, the connection to 3i Atlas was immediate and obvious. Memes were created, videos were edited, and threads were written arguing that the comet was emitting EMPs or that its gravity was affecting the sun, which in turn affected Earth. The cosmic and the cyber had merged into a single, intoxicating conspiracy. This is the modern information ecosystem in action. An event occurs. The official sources are slow or silent, decentralized communities, operating on a mix of intuition, pattern seeking, and sometimes malicious intent, rapidly generate alternative hypotheses. These hypotheses are not burdened by the need for evidence. They are judged by their narrative appeal, their emotional resonance, and their ability to provide a simple, satisfying explanation for a complex and frightening situation. The 3i Atlas theory was particularly potent because it combined a real, mysterious astronomical event with a real, disruptive technological event. It created a story that was bigger than a mere software bug, a story that placed humanity at the center of a cosmic drama. This is not a new phenomenon. From the War of the Worlds broadcast to the Y2K panic, we have always woven technological anxiety into narratives of external threat. The internet simply amplifies and accelerates the process, allowing these narratives to form and solidify before the truth has even put its boots on. The AWS outage and its subsequent narrative wars are a case study in how a complex technical event is instantly translated into a multitude of cultural and political symbols. The event itself was a failure of technology. The response was a mirror of our collective psychology, our fears, and our deep-seated need to find meaning, even, or especially, in the breakdown of the systems we rely on. As we approach the conclusion of this investigation, we must confront a humbling and fundamental truth. There are absolute limits to what we can know. Our understanding of both the digital failure and the cosmic event is bounded by insurmountable barriers. In the case of the AWS outage, the complete, unvarnished truth resides in the proprietary logs, code, and internal postmortems of Amazon Web Services. That information is a corporate asset, and it is highly unlikely to ever be released in its entirety. We will likely receive a sanitized, high-level summary that explains the technical chain of events without revealing the specific software vulnerabilities, the precise human errors, or the full extent of the architectural flaws that were exposed. The deepest root causes will remain hidden behind a wall of corporate secrecy and competitive advantage. We are, in effect, outsiders trying to diagnose a patient by reading the press release from the hospital's public relations department. Our picture is incomplete by design. In the case of 3i Atlas, our knowledge is bounded by physics and geometry. The weeks it spent in solar conjunction represent a permanent gap in our data. We have no observations of the comet during its perihelion. We do not know if it survived intact, if it fragmented, or if it exhibited spectacular outbursts. Any claims about its behavior during that period are, and will forever remain, speculation. We can extrapolate from what we saw before and after, but the climax of its solar encounter is a closed book. This is the nature of astronomy. We are passive observers of a universe that does not care about our schedules or our blind spots. These two knowledge gaps, one corporate and self-imposed, the other cosmic and absolute, create a permanent space for uncertainty. They are the fertile ground where speculation grows. We can fill these gaps with the most likely explanations based on available evidence, but we cannot claim certainty. This is not a failure of investigation. It is a feature of reality. The quest for absolute knowledge is a fool's errand. A more mature and more honest approach is to define the boundaries of our knowledge, to state clearly what we know, what we don't know, and what we can never know. In the case of the October 2025 coincidence, we know the timing. We know the independent causes are plausible. We know there is no evidence of a connection, but we can never know with metaphysical certainty that no connection exists. To claim otherwise would be to overstep the bounds of science and reason. The most rational position is to accept the overwhelming weight of the evidence for coincidence, while simultaneously acknowledging that the final, absolute proof is forever beyond our grasp. Whether the events of October 2025 were linked or not is, in a practical sense, almost irrelevant. What matters is that their coincidence has illuminated a set of profound and interconnected vulnerabilities. A prudent civilization would look at this pattern of systemic stress, the cable cuts, the solar near miss, the cloud outage, and not ask, who did this? But rather, how do we make ourselves more resilient? This is the essence of the precautionary principle, acting to reduce risk in the face of uncertainty. The solutions are not simple, but they are clear. For our digital infrastructure, we must move away from dangerous centralization. The reliance on a single cloud provider's region for critical services is a recipe for disaster. The future must be multi-cloud, hybrid cloud, and federated. It must involve a serious investment in decentralized technologies that are not dependent on these centralized choke points. For our physical infrastructure, we need to diversify the routes of our submarine cables and harden our power grids against geomagnetic storms. The technology exists. What is lacking is the political will and the massive investment required. For our cosmic awareness, we need to invest in a distributed network of space-based observatories. Relying solely on ground-based telescopes leaves us vulnerable to geometric blind spots like solar conjunction, a fleet of small dedicated telescopes in solar orbit, or at Lagrange points, could provide continuous monitoring of objects like 3i Atlas, ensuring we never again miss the most dynamic part of a rare visitor's journey. We also need to enhance our space weather forecasting capabilities and integrate space weather data directly into the operational planning of power grids and satellite operators. The May 10th near miss was a warning. We would be fools to ignore it. The coincidence of October 2025 should be a wake-up call. Not to look for aliens or hidden conspiracies, but to look in the mirror and acknowledge the fragility of the world we have built. It is a call to action to build systems that are anti-fragile, that can withstand shocks and even benefit from them. The goal is not to prevent every outage or to observe every comet, but to create a civilization that can endure the inevitable failures and blind spots without collapsing. The next coincidence might not be so benign. The next solar storm might not be a near miss. The next cloud outage might coincide with a geopolitical crisis. By strengthening our systems now, we prepare for the day when coincidence is not just a curious story, but a genuine threat. After this deep and sprawling investigation, where do we land? Let us synthesize the evidence one final time. The AWS US East 1 outage on October 20th, 2025 was a severe, cascading technical failure within one of the world's most critical cloud regions. Its cause was internal and technical, rooted in the immense complexity and hidden interdependencies of modern cloud architecture. The solar conjunction of 3i Atlas on October 21st, 2025 was an inevitable astronomical event, a result of the object's orbit and the fixed geometry of our solar system. The temporal proximity of these two events, within a 48-hour window, is a striking coincidence. It is the kind of coincidence that captures the imagination and triggers our deep-seated cognitive bias for pattern recognition. However, after examining the evidence from every conceivable angle, we find no credible mechanism, no forensic data, and no logical pathway to connect these two events in a causal relationship. The space environment was not a factor. The comet itself possessed no known property capable of influencing Earth's technology. The outage patterns were consistent with internal failure, not external attack. The rational conclusion, the one that aligns with all available data and the principles of Occam's razor, is that this was a meaningful coincidence, meaningful in the narrative sense, but meaningless in the causal sense. So, is there a signal in this noise? Yes, but it is not the signal some might hope for. The signal is not that a comet disrupted the internet. The signal is that our global technological system is brittle. The signal is that our cosmic awareness is limited. The signal is that we are psychologically wired to see connections where none exist. These are the real takeaways. The value of this investigation is not in proving a fantastical link, but in using the compelling narrative of the coincidence as a vehicle to explore these deeper, more important truths. We have dissected the anatomy of a cloud outage and understood its implications for the future of the internet. We have followed the path of an interstellar comet and confronted the limitations of our astronomical tools. We have seen how our own minds can weave compelling stories from random threads. In the end, the story of October 2025 is a story about us, about the world we have built, the universe we inhabit, and the minds we use to interpret both. The coincidence is the hook, but the investigation is the prize. Despite our thorough analysis, several key questions remain stubbornly unanswered, their shadows stretching beyond the reach of our current knowledge. These are not the questions of conspiracy, but the questions of a responsible investigator seeking a complete picture. First, the Amazon question. What was the precise root cause of the cascading failure? Which specific service or subsystem failed first? And what was the exact sequence of events that allowed a localized problem to escalate into a regional catastrophe? Until Amazon releases a full, transparent, and technically detailed post-mortem, this question will linger, leaving room for doubt and speculation. Second, the cosmic question. What did 3I Atlas do during its solar conjunction? Did it behave as predicted, or did it surprise us? As the comet re-emerges from the sun's glare in the coming weeks, astronomers will be watching intently. Any deviation from its predicted path or brightness could indicate activity we missed, a secret it kept while hidden from our view. Third, the preparedness question. In the wake of this outage and the March cable cuts, are cloud providers and governments taking meaningful steps to decentralize critical infrastructure? Are we moving towards a more resilient federated model, or are we simply adding more complex layers to the same fragile core? The answer to this will determine our vulnerability to the next, inevitable failure. Fourth, the psychological question. How do we, as a society, better equip ourselves to handle the cognitive dissonance of random high-impact events? How do we cultivate a public discourse that can hold rational skepticism and open-minded inquiry in balance, without falling into the traps of credulity or dogmatic denial? These unanswered questions are not a failure of this investigation. They are its legacy. They are the threads that remain loose, the paths that lead onward. The story of October 2025 is not a closed case. It is an ongoing event in a world of increasing complexity and interconnected risk. The coincidence may fade from memory, but the vulnerabilities it highlighted will remain. The work of understanding them and of building a more resilient future is just beginning. The investigation continues. As the calendar marches toward late November and early December of 2025, the astronomical community holds its collective breath. This is the expected reacquisition window for 3I Atlas. The comet, having completed its slingshot around the sun, is now predicted to emerge from the blinding solar glare, returning to a part of the sky where Earth-based telescopes can once again lock onto its faint, fleeing light. This moment is the scientific payoff, the end of the forced silence. Observatories from Hawaii to Chile to the Canary Islands have precious telescope time booked for this specific purpose. Their mission is twofold. First, to simply find it, confirming its survival of the perihelion passage, and second, to conduct a frantic, detailed forensic analysis of its condition. They will measure its brightness with photometry, analyze its composition with spectroscopy, and chart its precise position with astrometry. Any deviation from its predicted path could be a clue, not to alien intent, but to the natural physics of outgassing. As volatile ices sublimate from the comet's surface, they act like tiny, asymmetric rocket engines, imparting a slight nudge that can gently alter its trajectory. Measuring this nudge provides critical data about the comet's composition and structure. The most significant question is one of fragmentation. Did the intense solar heat cause the nucleus to crack or even split apart? If 3I Atlas re-emerges as a single bright point, it will suggest a relatively robust structure. If it appears as a diffuse, fuzzy cloud, it may have disintegrated entirely. And most tantalizingly, if it appears as two or more distinct fragments trailing one another, it will confirm a breakup, providing a natural laboratory to study the internal strength or weakness of interstellar material. The data collected in these first few days and weeks after re-emergence will be pored over by scientists for years, forming the definitive chapter in the brief story of this visitor's passage through our system. For the narrative we have been following, the re-emergence is the final piece of astronomical data. It will either show a comet behaving exactly as expected, thus reinforcing the coincidence narrative, or it will reveal something anomalous, which, while almost certainly natural, would forever color the story of its passage with an extra layer of mystery. The wait is a tense one. It is a reminder that in astronomy, patience is not just a virtue. It is a fundamental requirement. The universe reveals its secrets on its own schedule, and all we can do is point our telescopes and hope the clouds, both atmospheric and cosmic, part in our favor. In parallel to the astronomical watch, another form of observation is underway in the corporate world. Behind the closed doors of Amazon Web Services, a large team of engineers and managers is almost certainly finalizing a detailed incident report, often called a post-mortem. This document is a cornerstone of modern software engineering culture, a brutally honest, unflinching look at what went wrong, designed not to assign blame, but to prevent recurrence. The technology world awaits this document with an anticipation that rivals the astronomers awaiting 3i Atlas. When it is released, likely by late 2025 or early 2026, it will be dissected with the intensity of a sacred text. What should we look for? A truly transparent post-mortem will provide a minute-by-minute timeline of the failure, identifying the root cause with precision. Was it a specific line of faulty code deployed during a routine update? Was it a latent bug in a monitoring service that only triggered under a unique combination of load and network conditions? Was it a cascading failure that started in an unexpected place, like the identity and access management system, which then propagated to the network layer and the database services? Beyond the technical specifics, the most telling part of the report will be the section titled Remediation or Lessons Learned. This is where Amazon will outline the steps it is taking to ensure this specific chain of failure cannot happen again. Will they be architectural changes, such as decoupling critical services to reduce interdependency? Will they be procedural changes, such as new safeguards for deployments, or more rigorous game day testing, where engineers deliberately break parts of the system to test its resilience? The depth and ambition of these remediation steps will be a clear indicator of how seriously Amazon is taking this event. A shallow response would suggest they view it as a one-off, unfortunate fluke. A deep, systemic response would be an admission that the outage revealed fundamental flaws in their design philosophy. Furthermore, the report's tone will be scrutinized. Does it take full responsibility, or does it obfuscate behind jargon? Does it acknowledge the massive downstream impact on customers and the global economy, or does it treat the event as an internal technical matter? The release of this document is not just a technical formality. It is a moment of corporate accountability. For everyone who depends on the cloud, which is to say, nearly everyone, it is a report card on the resilience of the infrastructure that underpins modern life. Its findings will ripple through the entire industry, influencing best practices at Microsoft, Google, and every other cloud provider, shaping the digital world for years to come. The cascading failures of 2025 have not gone unnoticed in the halls of power. The Mediterranean cable cuts, the AWS outage, and the solar near-miss have collectively served as a deafening wake-up call for governments and international regulatory bodies. The realization is dawning that critical national infrastructure is no longer just about roads, bridges, and power plants. It is increasingly about data, connectivity, and the cloud platforms that host them. In the United Kingdom, the move to formally designate major cloud providers as critical third parties is gaining rapid momentum. This is not a symbolic gesture. It would subject companies like Amazon, Microsoft, and Google to a new level of government oversight, potentially including mandatory resilience standards, required transparency during incidents, and stress testing of their systems against scenarios like coordinated cyber attacks or severe space weather. The European Union is pursuing similar frameworks through its Digital Operational Resilience Act, DORA, and the Cybersecurity Resilience Act, aiming to create a continent-wide standard for digital infrastructure toughness. In the United States, where regulation often lags behind innovation, the conversation is more fragmented but equally urgent. Hearings are likely being scheduled in congressional subcommittees focused on homeland security and cybersecurity. Testimony will be heard from technical experts, industry leaders, and intelligence officials. The core question they will grapple with is the same one we have explored. How do we mitigate the risks of centralization without stifling the innovation and efficiency that centralization provides. The policy solutions are complex and fraught with political challenges. They could include incentives for companies to adopt multi-cloud strategies, grants for research into more decentralized internet architectures, and the establishment of a federal digital resilience agency. There will be fierce pushback from tech giants who argue that heavy-handed regulation will make systems more complex and less secure. This political and regulatory struggle is the next great frontier in the story of our digital world. The outages of 2025 are the catalyst. The outcome of this policy debate will determine whether the digital infrastructure of 2030 is more fragile or more resilient than it is today. It is a battle over the very blueprint of our future, and it is being fought right now in legislative chambers and regulatory agencies around the globe. Throughout this investigation, we have focused on systems, infrastructure, and cosmic phenomena. But we must never forget that these abstract concepts have a direct and profound impact on human lives. The true cost of a blind spot is measured not in terabytes or astronomical units, but in human experience. On October 20th, 2025, a small business owner watched in horror as her online storefront, hosted on a platform dependent on AWS, went dark during her peak sales hour, vaporizing a day's revenue and eroding customer trust. A freelance graphic designer in another country found himself unable to access the cloud storage where all his active projects and client files were kept, leaving him unable to work and facing angry emails. A family trying to check on an elderly relative via a cloud-connected camera were met with a frustrating offline message, their worry amplified by the silence. These are the invisible casualties of infrastructure failure. Similarly, the astronomical blind spot has a human cost, though it is measured in a different currency, the currency of knowledge and wonder. For the astronomers who had dedicated months to tracking 3I Atlas, its disappearance behind the sun was a profound professional frustration. It was the loss of a unique opportunity, the tearing of a crucial chapter from the book they were trying to write about the cosmos. For the public, it was the interruption of a story, a fleeting connection to the vast, mysterious universe beyond our solar system that was suddenly and temporarily severed. This human dimension is the ultimate argument for resilience. Building robust systems is not an abstract engineering goal. It is a moral imperative to protect the livelihoods, safety, and intellectual pursuits of billions of people. Cultivating cosmic awareness is not just a scientific hobby. It is a fundamental part of understanding our place in the universe. When our systems fail and our vision is obscured, we are not just losing data or observational time. We are dimming the light of human enterprise and curiosity. The man staring at his frozen banking app and the astronomer staring at a sun-blinded telescope are, in that moment, united by the same emotion, the frustration of being cut off from something they need, something they rely on, something that defines their connection to the world and the cosmos. It is this shared vulnerability that makes the pursuit of resilience and awareness a truly human endeavor. So where does this leave us? The investigation is complete, the evidence weighed, the scenarios mapped. The inescapable conclusion is that the AWS outage and the conjunction of 3I Atlas were a spectacular coincidence, a narrative quirk of timing that revealed far more about our own vulnerabilities than about any hidden connection in the cosmos. The legacy of October 2025 will not be the discovery that a comet can switch off the internet, but the dawning realization that we have built an internet that can be switched off, and that we look at a universe full of events we consistently miss. The lasting impact of this moment should be a new, sustained vigilance, a commitment to seeing our blind spots not as inevitable failures, but as solvable challenges. This means investing in the unsexy hard work of infrastructure resilience, funding multi-cloud R&D, mandating transparency from tech giants, and hardening our physical networks. It means expanding our sensors into the cosmos, deploying space-based telescopes to eliminate geometric blind spots, and enhancing our space weather forecasting to give us more than just a day's warning of a solar storm. But most importantly, it means cultivating a new mindset. We must become comfortable with complexity and uncertainty, yet relentless in our pursuit of robustness. We must embrace our role as both builders and observers, recognizing that the systems we create and the universe we observe are both filled with patterns and surprises. The coincidence of 2025 was a lesson in humility. It reminded us that for all our technology, we are not in control, but it also revealed a path forward, a path defined not by fear of the next coincidence, but by a determined effort to build a world that can withstand it. The story of 3i Atlas and the great outage of 2025 will eventually fade from headlines. But the questions it raised should echo indefinitely. They are the questions that will guide us toward a more resilient and aware future. The work continues. The watch must never end. Thanks for watching.